Okay, 1.1, that's what we're going to look at today, which is all about graphs. Okay, basics of graphs, introductions of graphs, and then we've got a few specific things that we'll learn and may or may not be reviewed to you. I don't know. Okay, so coming up, you'll have homework over this stuff due Sunday and Monday, which I'll post right after class. A group problem on Monday and a quiz on Wednesday. So it's coming up. Okay? So 1.1 is all about graphs, like I said. So that's a basic graph, right? Here's your Cartesian plane. Oops. Hang on. There's your Cartesian plane, right? With your x-axis going horizontally, your y-axis going vertically. Okay, so for example, the point 3, 4, right, has x-coordinate 3, y-coordinate 4. The quadrants are labeled quadrant 1, 2, 3, and 4 using Roman numerals as typical. Okay, it goes counterclockwise. Okay, you've got your x-axis, your y-axis. All right, first thing we're going to look at is how to find distance between 2 points that are in the plane. Okay, how to find distance? Well, it comes from the Pythagorean theorem, so this is an explanation. Okay, so if you want to find the distance between points P, with coordinates x1, y1, and Q with coordinates x2, y2, okay, basically you can turn it into a triangle to find the distance between them and then use the Pythagorean theorem, which says one leg squared plus the other leg squared equals the hypotenuse squared, right? The absolute value of x2 minus x1, that's this distance between those 2 points. Absolute value of y2 minus y1 is that distance. So when you square that distance plus the square of that distance, you get the square of the hypotenuse of the triangle. So you take the square root of both sides of this equation and you get this. And what you end up with is the absolute value of x2 minus x1 squared. Okay, but if you square something, it makes it positive anyways, right? So the absolute value bars are just a little bit redundant. So right here I've dropped those. But this gives you the distance between P and Q. D of PQ means distance from P to Q. It's the square root of x2 minus x1 plus y2 minus y1. Okay, so let's find the distance between these 2 points. P1, which is -4, -3, and P2, which is 6, 2. Okay, it's just a straight application of this distance formula right here. Does it matter which point you call x1, y1, or which point you call x2, y2? No, right? It doesn't matter. So I'm just going to go in order. We'll call that one x1, y1, and this one x2, y2. Okay, so then the distance between P1 and P2 is equal to the square root of, okay, x2 minus x1, that's 6 minus -4, all squared. Okay, plus y2 minus y1 is 2 minus -3, all squared. Okay, so this becomes 6 plus 4, right, or 10 squared, plus 2 plus 3 is 5, 5 squared. So it comes to the square root of, right, 125. Okay, is the exact distance. And then we want to see if that simplifies. It's not a perfect square, right? 125. 125, if we divide that by 2, we get, not by 2. What small prime number can we divide 25 by? 5. Prime numbers, 5. So I get 25. I can divide that by 5, and I get 5. So I can pull what out from the radical 125? A 5, right? Because there's 2 of those. That's like 5 squared under the radical. So I can pull that 5 out front. Anything there's 2 of. Anything that's left over stays under the radical. So that 5 is there. So that's the exact distance, and you could approximate it if you want, right? But your answer is 5 root 5. Okay, do you have any questions about how to use the distance formula? Okay. There we go. Okay, so yes.
If you actually not realize that could be very simple, would you get knocked down?
It depends. Okay, generally you want to simplify. And part of why I'm doing this is just to practice simplifying with you guys. Yeah. Well, my math lab will well, it's kind of picky sometimes. If it doesn't say simplify, it should accept both versions. Yeah. It depends on like the problem you're doing and how many points it's out of as to whether or not I would take off for that, because it kind of depends. Okay. We have a triangle given by these 3 points, PQR. Is it isosceles, meaning two sides of the same length, equilateral, all three sides the same, or scalene? How are you going to tell? Well, you're just guessing. I don't know. All right, how do you tell? We're going to find the distance between each of these points, okay? And then see what we get. So let's plot them first, too, just so we have a picture. So P is -3, 3. Q is -3, 7. Okay, that one's kind of easy. And R is -3 plus 2 root 3, comma 5. So I don't know what that is. We need to get an approximation for that. Okay, so let's see. We want to do -3 plus 2 root 3. So let's do 3, take the square root. So that's the square root of 3. Now I'm going to do times 2, and then minus that 3 right there. Okay, so that x-coordinate is about 0.464. Okay, that's just the decimal approximation of this. That's approximately 0.464, comma 5. So I need that decimal approximation so I can graph it, right? Because otherwise I don't know where to put it. So it's close to a half, comma 1, 2, 3, 4, 5, right about in there. So that's R. Okay, so we're going to find these three distances and then see if we get the same thing. You guys, right here and right here, find the distance between P and Q. And then everybody right here, here, and here, find the distance between Q and R. Everyone else, find the distance between P and R. Okay? Okay, I found the distance between Q and R, so you can check with what I've got here. Okay, so I've done x2, is that 5? Oh no, I did my y's first, didn't I? It doesn't matter. Well, I did y2 minus y1 first. So 5 minus 7 is the x2 minus the x1, y2 minus the y1 squared. And then the x2 is this, -3 plus 2 root 3, that's all my second x-coordinate, minus -3, so minus -3 becomes plus 3, all squared. Luckily, the 3's cancel, right? Makes it a lot simpler. If the 3's hadn't canceled, you'd have to FOIL that out, okay? But the 3's canceled, so then you're left with the 2 root 3 squared for the second term. Okay, 5 minus 7 is -2. -2 squared is 4. Simplifying, 2 root 3, all squared, right? Both things inside are squared, so you square both the 2 and the radical 3. Okay, so you get 4 times 3, or 12 plus 4 is 16. So I'm getting 4 for the distance between Q and R. Is that what y'all got? Middle group? Okay, now PQ, that one's easy because you can actually just count the boxes there, right? But if you write it all out, what do you get? You should still get 4. And what did y'all get for PR? Anybody? The distance between P and R. Isn't that y'all over here? What'd y'all get?
Around like 4.
Exactly 4 or close to 4? Well, you shouldn't be using a calculator at all. Is it exactly 4? Should we do this one?
Yeah.
Okay. I was going to skip it, but I'm not going to. All right, so let's see, what are we doing? P and R. Okay. x2 minus x1, right, is going to be negative 3 plus 2 root 3. That's my first x coordinate. Minus negative 3 will become plus 3, all squared. Plus y2 is 5 minus x2 is 3. So 5 minus 3 squared. The 3's cancel again, right? Negative 3 and plus 3, those cancel. Okay, so we have 2 root 3 is the same thing. We have 2 root 3 all squared plus 2 squared is 4. Okay, if we square the 2, we get 4. If we square the square root of 3 right here, we get 3. So 4 times 3 plus 4, that's 12 plus 4 is 16, same thing. Okay, so all the side lengths are 4, so it's equilateral. Yes?
So it doesn't matter if you do x1 and x2 first or y1 and y2?
Right. I mean, order in which you add things. Oh, doesn't matter. Okay, order that you add things doesn't matter. Right, 1 plus 2 equals 2 plus 1. I didn't do that on purpose. That's just what I wrote. You gotta get on the phone with Microsoft again. Are there any other questions? Okay. All right, midpoint formula. That tells you the midpoint between 2 points, the point halfway in between 2 other points. Essentially, you take the average of the x-coordinates, okay, add them and divide by 2, and then the y-coordinate of the midpoint is the average of your 2 y-coordinates, okay, which we'll graph this one, and you'll see visually that it works. So we're going to find the midpoint of the line segment joining the points P1, which is negative 4, negative 3, and P2, which is 2, 2. So I'm going to plot those first while y'all write. And sketch in the line connecting those 2 points. We're going to find the midpoint. So M for midpoint would be, following this formula, x1 plus x2, so negative 4 plus 2 divided by 2, comma, y1 plus y2 is negative 3 plus 2 all over 2. So that simplifies to negative 2 divided by 2 is negative 1. Negative 3 plus 2 is negative 1/2. So it's telling me negative 1, negative 1/2. Does that appear roughly correct there? Okay. So that's the midpoint. Average of the x-coordinates, comma, average of your y-coordinates. Do you have any questions about that? Okay. That can be useful at times. All right, what is a graph? I know you know this, right? But one way to think about a graph is that it's the graph or display of all of the little coordinate points that make an equation true. So if you have a coordinate point x, comma, y that you can plug in, right, and it satisfies the equation, and you plot like all these infinitely many little dots, you're going to get the graph of an equation. There's all kinds of graphing techniques which we're going to get to, so I'm not going to go there now. For now we're just going to see if, or look at how to see, if a certain point is on the graph. What do we want to do with the point 0, 0 to see if it's on the graph of this equation? Plug it in, right? If it works, then it's on the graph, otherwise it doesn't. So let's plug in 0, comma, 0. And we're going to check and see, does it satisfy this equation right here? Y equals x cubed minus 2 root x. So x and y are both 0, so does 0 equal, question mark, does it equal 0 cubed minus 2 times the square root of 0? All right, 0 cubed is 0. What's the square root of 0? Also 0, so we do get 0 on the right also. So that one works. Okay, so the point 0, comma 0 is on the graph of that equation. All right, you check the next one. Is 1, comma, negative 1, is that on the graph? Okay, that means x is 1, y is negative 1. So if I replace this y by negative 1 and the x by 1, do we get a true equation?
Yes.
Yeah, 1 cubed is 1. Square root of 1 is 1, so 1 minus 2 is negative 1, so yes. So that one also works. If you got like 1 equals 0 or some false equation, then it would not be on the graph. Do you have any questions about how to tell if a point is on a graph? Of course it is. Okay. Oops. There we go. Okay. I'm not going to plot points and graph that way. I don't have time. You have done it before, probably many, many times. So if you want to see a review of that, you can go here and search for that particular video. It's a good one. If you are in Canvas looking at the blank notes and you just click the link, it should actually take you there. Okay. Basically, you pick an X, right, and plot the corresponding Y. We're going to learn all kinds of graphing techniques throughout the whole next couple chapters, so that's why I'm not going to take time to do it. Okay, we're going to jump ahead to intercepts. So an intercept is a point at which a graph crosses or touches an axis. So you've got x-intercepts. Now if you're on this x-intercept, what is the value of y? If you're on the x-axis, yeah, y equals 0, right, for all of the x-intercepts. So in order to find x-intercept, you set y equal to 0 and solve for x. Okay, or y-intercepts, they occur on the y-axis where x is 0. So to find y-intercepts, you set x equal to 0 and solve for y. Okay, and this works for any kind of equation, you know, linear, quadratic, rational, radical, whatever. I think there's one of each of those 4 in your homework, actually. This always works, okay? So we're going to find the x and y intercepts of this graph. Later we'll learn more about graphing parabolas and quadratics, but for now we're just going to find the intercepts. And I like to start with the y-intercept because it's a little bit easier, generally. So if we want to find the y-intercept, we're going to set x equal to 0 and solve for y. So if I plug in 0 for x, I get y equals 2 times 0 squared minus 5 times 0 plus 1. So I get 1 for my y-intercept. That's pretty straightforward, just plugging in 0 for x. To find x-intercepts, though, I need to set y equal to 0. Okay, so we're going to have 0 equals 2x squared minus 5x plus 1. What kind of equation is that? Quadratic. Is that going to factor? No, it's not, because the last two terms would have to multiply to 1, to positive 1, if it was to factor. I don't know. 1, 1. They both have to be negative to multiply to positive 1 and add to negative 5. One of my beginning terms would have to be 2x, and the other would have to be x to multiply to 2x squared. But that doesn't give me negative 5. That gives me a negative 3x for my middle term, not negative 5x, right? Okay, so that doesn't work. So how do we solve it? Quadratic formula, go! Solve that equation using the quadratic formula. Okay, so b is negative 5, so negative b is positive 5. Plus or minus the square root of b squared is going to be 25. Minus 4 times a is the coefficient of x squared, which is 2. Times c is positive 1. All over 2a is 2 times 2. What do we get under the radical? 17. Does that simplify? No, that's prime. So that's not going to reduce at all. So those are your two x-intercepts. I should probably label x-intercepts. Or if you want, you could write it as like, this is the x-coordinate, so it would be that comma 0, that comma 0. Your y-intercept, let's just write it. What are the coordinates of the y-intercept? 0, 1, right, x is 0. Or over here, those are your x-coordinates, so you'd have 5 plus root 17 over 4, comma 0, and 5 minus root 17 over 4, comma 0. I'm not real picky whether you write it as a coordinate point or you just put x-intercepts are these, you know. I know that you understand either way. Okay. So what are your questions on that one?
Will we ever have to solve to see if both of them are actual intercepts?
They are always actual. Like if you're solving, and as long as you don't get a negative under the radical, yeah, then those are intercepts. You don't have to check your work, no. Is that what you mean? Yeah, unless you want to. Which is fine. There's no harm in checking your work. Okay. There we go. Okay. Symmetry. That's the next topic. All right. What does symmetric mean? So something is symmetric if it's like a mirror image. Okay. So a function, or I shouldn't use that term, a graph is symmetric about this y-axis if the y-axis is like a mirror. Right. So it's reflecting itself over that. Or this would be symmetric about the x-axis because it's like a mirror image over that axis. Symmetric about the origin is a little bit different. Okay, it's like you flip both, or you can think of it as kind of taking this graph and then rotating it about that point 180 degrees. That's what I kind of picture. Okay, just rotating the graph around from that center origin point. So that one's symmetric about the origin. Okay, notice the points. On the one that's symmetric about the y-axis, if x comma y is on the graph, what's the corresponding point on the other side of the mirror? Negative x comma y. The y-coordinate is the same. They have the same height. But over here, that x-coordinate is positive x, and over here it's negative x. Okay, so a graph is symmetric about the y-axis if, skipping down here, if for every point x, y on the graph, the point negative x, comma, y is also on the graph. Okay, if that's true, then it's symmetric about the y-axis. Or about the x-axis, right? A graph is symmetric with respect to the x-axis, is for every point x, y on the graph, the point x, comma, negative y is also on the graph, which you can kind of see visually right here. The mirroring points have the same x-coordinate but opposite y-coordinates. Okay. Okay, or it's symmetric about the origin if both of those things are true. So if for every point x, y on the graph, the point negative x, comma, negative y is also on the graph. You actually flip it both ways, over the x-axis and over the y-axis, if it's symmetric about the origin. Okay, how do you tell if a graph is symmetric? It's using this idea, okay, about the points and the corresponding points being on there. So how do you tell or test for symmetry? Ready for me to go down a little more? Okay, so to test for symmetry about the x-axis, because the corresponding point is x, comma, negative y, you replace all the y's with negative y and simplify. If you get the same thing, you get the original equation back, then it's symmetric about the x-axis. To test for symmetry with respect to the y-axis, okay, you replace each x with negative x, because that's the corresponding point when you flip over the y-axis, and simplify. And to test for symmetry about the origin, you replace x with negative x and y with negative y and simplify. And if after simplifying you get back the original equation, then it is symmetric with respect to either that axis or the origin. Okay, so we're going to test the equation, the one right there. We're going to test that for symmetry about the x-axis, the y-axis, and the origin. Okay, and then we'll look at the graph so you can just visually see what that looks like. Okay, so first let's test for symmetry about the x-axis. So to test for symmetry about the x-axis, we need to, up here, we need to replace y with negative y and simplify. Okay, and see if we get the same thing. So I'm going to replace this y right here in this equation by negative y. So I'd have negative y equals x squared minus 4 over 2x. There's really not a lot to simplify here. I mean, you can multiply both sides by negative 1 to move it over if you want, but regardless, even if you do that, is it going to simplify back to this original equation? No. So this would not be symmetric about the x-axis. Okay. So this is not equal or not the same as the original equation. So its graph is not symmetric about the x-axis. Okay, so to test for symmetry about the y-axis, we replace x by what? Negative x and simplify. So now I'm taking the original equation again, but I'm replacing each of the x's with negative x. And be careful to put like that one on top there in parentheses. Makes a big difference. Okay, because now we can simplify this, and when we do, negative x times negative x is positive x squared, because the negatives cancel. You got negative times a negative. Okay, so this one becomes positive x squared minus 4, but the denominator is 2 times negative x, or negative 2x. It's still not the same as that, right? Because we have this negative down here that's not going away. So it's also not symmetric about the y-axis. Okay, last one. We're going to test for symmetry about the origin. So we're going to replace both x with negative x and y with negative y and simplify. So replacing this y, right here we have negative y equals negative x all squared minus 4 over 2 times negative x. Okay, the negative x, when we square that, again, we still get positive x squared equals x squared minus 4. And I can simplify further here because I have a negative on both sides. Right, so if I multiply both sides by negative 1, right, then those negatives cancel. That negative cancels with that negative. And then the negative in the denominator on the right cancels with the negative in red, so we get y equals x squared minus 4 over 2x, which I can't seem to fit it all on the screen. I guess I can zoom out a little. Okay, but that is the exact same as the original equation. Okay, so this one is symmetric about the origin. Yes? Well, multiply both entire sides by negative 1. Right, so I've got a negative here times that negative there. They cancel. We get positive 1. How come it doesn't have a negative what? I'm deciding to put the negative down on bottom instead of up top because that's where this negative is. I mean, you could move the negative around. Hold on, let me write this. So it is, okay, symmetric about the origin. Okay, so let's take this. Let's do some black up here. Okay, so if you have x squared minus 4 over negative 2x, that's the same as the negative of x squared minus 4 over positive 2x. You can move, you move the negative to the top, out front, or on bottom. They're all the same. Okay, so, or I could put the negative on top and have the negative of x squared minus 4 all over 2x. Now, you could distribute the negative and write it as negative x squared plus 4, but then when I multiply by this negative 1, regardless, this negative cancels with that negative, regardless of where I write the minus, whether I write it down here, up top, or out front. Am I answering your question? Okay, so it doesn't really matter where placement, right? Okay, are there any other questions on this one? Let's check out the graph real quick. Okay, x squared minus 4 over 2x. I probably have it up already. I do. Yeah, x squared minus 4 over 2x looks like that, right? So you can tell if you imagine half of it, right? Rotate it 180 degrees. That's exactly what you're going to get, so that you can see it's symmetric about the origin. You can always check with the graph. It's an easy way to check. Yes? Okay. Let's go back to here. Okay. Circles, that's the last topic for today. We're going to look at graphs of circles. So a circle is a set of points that are at a fixed distance from a center point. Remember taking the compass, right, as a kid, pencil in the center with your string, right, and you draw a perfect circle. Y'all did do that as kids, right? Okay. Half the time I'm like, I remember when I did this and this in school, and my mom's like, they don't teach that anymore. I'm going, what? Okay, I'm not that old. All right, anyways, so I know you know what a circle is. R represents the radius, typically. Okay, HK is what we're going to use to represent the center. That's a pretty common variables to use, H and K, for your center. The standard form of an equation with center HK and radius R is this, okay? For now, I can't really explain where it comes from, although it's kind of related to the Pythagorean theorem as well. You kind of see, the term squared plus the term squared equals the constant squared. It's related to that. Has to do with the fixed distance thing. Okay, so that's the standard form. Make sure you memorize that standard form. Okay, what we're going to do is find the standard form of the equation of a circle with center negative 3, 4, and radius 7. And then we'll sketch a quick graph of that. Okay, so what is H? Yeah, H is negative 3. I'm going to plug in y minus k. So that's the center. K is 4. It's the y coordinate of the radius. And R is 7. So if we plug all that in to the standard form right there, we will get x minus negative 3. Right, which I'm going to write as x plus 3 in just a second. Plus, all squared, plus y minus k, or minus 4 all squared, equals 7 squared. Okay, if you simplify it, that's x plus 3 all squared plus y minus 4 all squared equals 49. Okay, I didn't leave room for a graph, did I? We'll do it on the board. So center is negative 3, 4. 1, 2, 3. And then the radius is 7 out from that. So here's how I would graph that, is just count 7 more up, right? So it's going to put us at 11. Right there. So that's 11. If I go 7 out to the right, that would put me at what x coordinate? I'm already at negative 3. So if I add 7 to that, yeah, I'm going to be out at 4. There. If I go down 7, I'll be at negative 3. Or to the left 7. Okay, so there's your circle. My intercepts are obviously a little off. It's not a perfect circle the way I drew it, but that's the idea. Okay, sometimes you might see an equation of a circle that's not in standard form. It's in what's called general form. Looks like this. It's basically everything's expanded and multiplied out, and one side equals 0. Okay, that's called the general form. If you have the standard form, it's pretty straightforward to put it in general form because you just FOIL all this out, combine like terms, and simplify, putting it all on one side. So let's do that first. Let's convert this, what we just found. This is, in my opinion, the better form, right? Because I can look at it and read off the center and read off the radius. I can look at that and go, oh, center is negative 3, 4, radius is 7. Right? It tells us information. This form tells you nothing. You can't look at that and tell anything, really. But we're going to expand it anyways. Okay, so if we FOIL that out, all of it, the x's and the y's, we'll have x plus 3 times x plus 3 plus y minus 4 times y minus 4 and then let's go ahead and move the 49 over to the left. So minus 49 equals 0. And then keep going and just check with what I do. Okay, when I FOIL all that out, I'm getting plus 6x for my middle term and minus 8y. Okay, then rearranging, I'm putting this y squared here and the 6x there. And then we need to combine all the constants. So 9 plus 16 is 25. Minus 49 is negative. So I got 25 minus 49, negative 24. Good. Equals 0. Practice your mental math. Okay, that's standard form. That's it. Or general form. That's the general form. Using the word standard and general don't really mean too much. I probably would call it the HK form or the expanded form. I think that's more descriptive. But I'm going with the terminology for your book here. Okay, now let's go backwards. That's the slightly harder thing to do. Because to go backwards and convert it from general form to standard form, you have to complete the square. Okay, it's not too bad. We'll do a couple of examples here. Well, actually, I'll do 3 total. Okay, so if you're given an equation of a circle in general form, I'm looking at this going, okay, I can tell it's a circle. Maybe you can, maybe you can't, but it's a circle. But I don't know the center, I don't know the radius, right? So we want to convert this general form into standard form so that we can know something about it, where it's at. Okay, so we want to rewrite it so that it's x plus or minus a number all squared plus y plus or minus a number all squared equals a constant squared. Okay, so first we're just going to rearrange. And then I'll complete the square. So let's put all the x terms together. So let's write it as x squared minus 6x. Put those together. Then leave a little space. Then let's put the y terms. So let's put plus y squared plus 8y. Leave a little space. And let's move the 10 over to the right. So equals negative 10. Okay, I left space because we're going to have to add some numbers in here and here to make these into perfect squares. Okay, so if we want x squared minus 6x plus some number to factor into x plus or minus a number all squared, okay, what I'm wanting is for that to be written as x plus or minus some constant all squared. Okay, we have to pick a constant so that when you square it and you FOIL this all out, like we did a second ago, your outside and your inside terms add to negative 6x. Are there any ideas what I might need to put here? Minus 3. Let's try minus 3. Okay, if we put minus 3 there, then when you square it out, let's just do this on the board, x minus 3 squared equals x minus 3 times x minus 3. So when we FOIL this, we're going to get x squared minus 6x plus 9. But I don't have a plus 9 over here, do I? Right, so we have to add that in. In order to rewrite these x's like this, we have to add a plus 9 here so that it factors into x minus 3 all squared. Okay, so we're going to add a plus 9. Now, if you add 9 to one side of an equation, what do you have to do to the other side to balance it? Also add 9, right? So let's put a plus 9 also on the right side. Okay, so here's the technique. I'll write it in words down here in a second. You look at the coefficient of the linear term, so of the plain x term. It's negative 6. Divide that by 2. That's what's going to go here. It's always divided by 2. Square this number, that's what you add to both sides. Okay? So let me write that down. So you take the coefficient of the linear term, the x, take coefficient of x, divide it by 2, and square it. Square that number. And then we're going to add that to both sides. Okay, we're going to have to do the same thing with the y's. Okay, to rewrite y squared plus 8y plus whatever we need to go there. So we can write it as y plus or minus a number all squared. That's called completing the square, okay? All right, so we're going to take this coefficient, which is positive 8, divide it by 2. That gives us positive 4. And then I want to square that number, 16. Okay, so you take the coefficient of the linear term, y, instead of x this time, divide it by 2 to get 4, and square that number to get 16. And we add that to both sides. So I'm going to put plus 16 on the left and plus 16 on the right. Now, if we did it right, this will factor into a perfect square. And it's always going to be y plus the number over 2. Right, it should be. So positive 4 all squared. If you FOIL that out, do you get back y squared plus 8y plus 16? Yes, right. If you FOIL that out just like I did with the x minus 3's, that's exactly what you get. Okay, so we've completed the square. Then on the right, you just add these numbers together. So negative 10 plus 9 is negative 1 plus 16 is 15. And that's the standard form. Okay, so what is the center of the circle? Okay, so we got x minus h squared compares to x minus 3 squared, so h is positive 3, because there's already a minus in the formula. So h is positive 3. Y minus k squared compares to y plus 4 squared, so what has k got to be? Negative 4, good, negative 4. So the center is 3 comma negative 4, and the radius is, it's not 15, it's the square root of that, right? Because it equals the radius squared. So the radius squared is 15, so the radius is square root of 15. Good? Awesome. What are your questions? Anybody? Okay, one more example then. Okay, which is very similar. Find the center and the radius of the circle given by 2x squared plus 2y squared plus 4y equals 0. Okay, this one's a little bit simpler. There's not a linear x term, right? We have a linear y term, 4y, positive 4y. So how are we going to write that? Well, actually, before we even do that, we've got two coefficients in front of the x squared and the y squared. Okay, which makes completing the square harder, but we can get rid of these coefficients by doing what? Divide both sides by 2, yeah. First I'm going to factor out the 2 just to be really clear. So I'm going to factor the 2 out from the left. Okay, divide both sides by 2. Okay, that makes it a little simpler. Then let's figure it out from here. So then we have x squared plus y squared plus 2y, leave a gap, equals 0. So my x, right, we don't actually have to complete the square because we want to be able to write it as x minus a number all squared. What number goes there? I can think of this as x minus what squared? 0. Yeah, x squared is the same as x minus 0 squared. So it's already done. We don't have to do anything. For the y's, though, we're going to have to add a number here. Don't say it out loud. Give everyone a chance to think about it. What do we need to add there to make this into a perfect square? Okay, what's the number? 1. Yeah, you take the coefficient of y, which is positive 2, divide it by 2, you get 1. 1 squared is 1. So we're going to add 1 on the left, so we also have to add 1 on the right. Then, does y squared plus 2y plus 1 factor into y plus a number all squared? Y plus 1, all squared. Okay, so that's it. Now the simplified version would be to not write the minus 0. That was just to illustrate. So I would actually write x squared plus y plus 1 all squared equals 1. So what is the center of the circle? Go ahead, 0, comma, it's x minus 0. This is you can think of as y minus negative 1. So 0, comma, negative 1. The radius would be square root of 1, which is 1. Okay, that's it for today. We didn't have time for a group problem, so we'll do a group problem on Monday and a quiz on Wednesday. And I'm about to go post your homeworks, which are due Sunday, Monday, and then on from there, okay?